Hi, my name is Devanan and the matrix number is C220129 and I'm from Group 8. Would like to present my manual solution for question 4A1. So let's go through it. And here the question says, consider the surface of the solid G bounded by the cone Z x z 4 minus x square minus y square and plane z equals to 0. So compute the flux of the water flowing through the surface theta if the velocity f vector f x I plus y j plus 2k, and assume that the unit vector is orientated outward. So this is the cone that I've sketched earlier, and this is the projection for the xy plane. So how do I get this projection is we use this formula. So z minus, this is the formula for cone. So 4 minus square root s2 minus y x square plus y square and z, and you will get the radius to substitute to draw the projection, and then you'll get the limits as well. So 0, theta 2 pi, and 0 r is between 0 and 4. So from z minus equals to 4 minus square root s2 plus y square. So we have to verify that we have to compute the flux. So we just have to like substitute. So dx stroke square root d delta z over delta z x square minus delta z over delta y2 square plus 1 dA. So by the given vectors, we have to substitute and create a double integral. So this one is from the orientated outward. So we times with the ds. So after that we have to just double integral it. So like x. So this one the limit is 4 to 0, then 2 pi to 0. So then after r dr theta because it's a cone. So r q z, and then we have to like so we have to do the integral like 4 first. Do the integral, then after that then verify is s square plus y square equals r square, then substitute it, then after that only we do the after that only we do the integral, then substitute the 4, then minus 0, and then next we create a integral for this, then 2 pi 0, we will get 2 to 4 over 3 minus 0, and 2 to 4 over 3 pi, the final answer. So that's it for me today, and next for the Maple solution, Shah and Daniel will share about how to get the Maple solver solution. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Lukman bin Zulkifli, matrix number TE210080. Today I will present this 4A2 question for multivariable calculus assignment. So this question asks to calculate double integral f and ds by applying Gauss theorem if the velocity vector is vector f equal to si plus yj plus 2k. So as you can see, we write back the equation in this form and we integrate each of value, which is I, j and k, and multiply it by the value of f, which is this, and dv. So for each limit we put for I or x we put 0 until 2 pi. For x we put 0 until 4, and for z we put 0 until 4 minus third r the power of 2, and we put back the integration we need, and we integrate it to r dr d theta. So we get the value which is 1 plus 1 plus 0 r dr d theta. We plus it, we get 2 tr dr d theta, and we integrate it again with the value of 0 and 4 with limit 0 until 4 minus third r the power of 2 r dr d theta. So we continue and we get this value, and we integrate again the value of dr d theta, and we put the second limit which is 0 until 4 for in this equation, which is 8r the power of 2 over 2 minus 2r the power of 3 over 3, and we integrate it again with the last value which is 0 to 2 pi. We get the 64 over 3 d theta, and we substitute the value into the equation, and we get the final value which is 128 over 3 pi, or equal to 134.04. I think that's all from my part. Thank you.
Okay, Assalamualaikum and good morning. My name is Muhammad Hafiz bin Sulaiman, DE 210044. Okay, I will continue for the explanation. So, I'm doing for the Maple simulation for Q4A. The question is, consider the surface of solid G are bounded by the cone Z equal to 4 negative square root x power of 2 plus y power of 2 and plane Z equal to 0. So, compute the flux of water flowing through the surface if the velocity vector F equal to xi plus yj plus 2k. Assume that the unit normal vector is oriented outward. Okay, this is for the equation, and if we use the equation and plot the 3D, we get the cone shape. This, if we cut here 0, it will form a cone shape 3D. Okay, after that we want to find the 2D plot for the cone. So this is the plot. So we get here, we can see that the R is equal to 4. After that, this is for the solution to find the double integral for the equation of cone. This is the formula that will be used to find for the double integral cone. Okay, from here we can see the 4 and the 0 is we get from here, which is the R. So we just insert the value, the is 0, R is 4 and 0 and also 2 pi. Okay, from here we can see from this equation we need to convert to R. So x power of 2 plus y power of 2 equal to R power of 2. So you can see here we get the simplified equation. Okay, after that the R is multiplied inside this bracket and we get this. After that, after we integrate the dr, then we need to integrate the d theta, and we will get the answer here. Okay, after that, the 4a2 is calculate by applying Gauss theorem. If the velocity vector f equal to si plus yj plus 2k. Okay, this is for the manual calculation. Okay, this is the calculation from the formula, and after that we just insert a number x dx, we will get 1, y dy we get 1, and 2 dz we get 0. And then we just integrate the number step by step from dz. We will get 8 negative 2 square root of r power of 2, and then we will integrate for the rdr, and we will get 64 over 3, and then we integrate 64 over 3 for d theta, and we get 128 over 3 pi. Okay, that's all for me. I will pass it for my next member. Thank you.
Assalamualaikum. My name is Azri Ikhwan bin Muhammad Badruddin, number matric CE 310067. Today I'm going to show the solution for question 4b. For the question 4b, let sigma be the portion of paraboloid where z equals to 4 minus x squared minus y squared, where z is greater or equals to 0 and oriented outward. Suppose that the curve C is the boundary of sigma in the xy plane and the force field is given by f equal to zi plus 6xg plus yk, and verify the Stokes theorem. When z equals to 0, we put the 0 into z. We got 0 equals to 4 minus x squared minus y squared. Now we change 4 to the left and we got negative 4 equals to negative x squared minus y squared. Now we change it to the positive. We got 4 equals to x squared plus y squared. As we know, x squared plus y squared is equals to r squared. And change the this equation to the r squared. We got r squared equals to 4. And the answer is r equals to 2. And this is the formula for n, where n equal to negative delta z over del x I minus del z over del y j plus k over square root del z over del x square plus del z over del y square plus 1. And this is the graph for the 3D graph and 2D graph xy plane. As we can see here, for 3D graph, z is 4, while x and y is 2. For the Stokes theorem, we use interval S using lambda times f times n ds equals to interval f dr. Now we express the unit vector for I, which is there over the x, and z. For vector g, we use there over the y and 6x. And lastly for k, there over their z and 1. So we put for I, we close this 1 and times that over the y to y, and we got 1 minus 0 I. For j, we times the del over the x times y and del over the x times z. So we got 0 minus 1 j. For k, we times del over the x times 6x and del over the y times z. We got 6 minus 0 k. And we got I plus p plus 6k. Using this equation, we put into the first equation, and we got integral s ij I plus p plus 6k times for n, as we know n is negative dz over dxi minus dz over dyj plus k over square root dz over the x square plus dz over the y square plus 1 times square root dz over the x square plus dz over the y square plus 1. For this, we know that x equals to r cos theta and y equals to r sin theta. Now, for the interval 0 to 5, interval 0 to 2 minus dz over the x minus dz over the y plus 6r dr d theta. Now z is equals to 4 minus z square minus z is equal to 4 minus x square minus y square. As we know, dz over the x equals to negative 2x and dz over the y equals to negative 2y. So we put negative 2x and negative 2y into their respective equation, and we got interval 0 to 5 and interval 0 to 2 to x plus 2y plus 6r dr d theta. Now, as I said before, we change the x into r cos theta and y into r sin theta. Now, where we need to times r into the equation, and we got 2r squared cos theta plus 2r squared sin theta plus 6r dr d theta. Now, we need to integrate dr. We got integral 0 to 5 bracket 2r squared over 3 cos theta plus 2r cubed. Now we need to integrate dr, and we got integral 0 to 5 bracket 2r cubed over 3 cos theta plus 2r cubed over 3 sin theta plus 3r squared over 2. For interval 0 to 2, we write down. Now, we got, after we integrate it, we got interval 0 to 5 bracket 12 plus 4 cos theta plus 4 sin theta d theta. Now we need to integrate the d theta, and we got 12 theta plus 4 sin theta plus 4 cos theta to find 0. And the question is, and the answer that we got is 24 pi. And lastly, we can verify that it that the answer is 24 pi. That's all from me. Thank you. Z is equal to 4 minus x squared minus y squared. As we know, then z over the x equals to negative 2x. And then z over the y equals to negative 2y. So we put negative 2x and negative 2y into their respective equation. And we got interval 0 to 5 and interval 0 to 2 to x plus 2y plus 6r dr dθ. Now, as I said before, we change the x into r cos theta and y into r sin theta. Now, we need to integrate the r, and we got integral 0 to pi bracket 2r cubed over 3 cos theta plus 2r cubed over 3 sin theta plus 3r squared over 2. For interval 0 to 2, we theta. Now, we got, after we integrate it, we got interval 0 to 2 pi bracket 12 plus 4 cos theta plus 4 sin theta d theta. Now we need to integrate the d theta, and we got 12 theta plus 4 sin theta plus 4 cos theta equal 0. And the question is, and the answer that we got is 24 pi. And lastly, we can verify that the answer is 24 pi. That's all from me. Thank you.
Hi, my name is Muhammad Shahrul Iman. I will present for the question 4B. For question 4B is paraboloid. For the 3D curve, we have z equal to 4 minus s square minus with y square. So in Maple, we have plot the graph for the z plane is 4 and the s plane is 2 and y plane is 2. View. For the 2D graph, we have s equal to, y equal to, and this for the 2D graph paraboloid. So for the last part is Stokes theorems. For in this one, we need to get the value del z, del x minus with del z, del y. So by using maple, we can get the value for the del z, del x is negative to x, del z, del y is negative to y. Same as the manual calculation. So for this value, we will insert in this integral equation, and by using maple, we can get the direct answer, which is 24 pi, and it is same as the manual calculation. So that's all from me. Thank you.